In this video, we have to take some questions on how to compute the Arima model. The Arima means the auto-regressive integrated moving average. So, for more on this topic, you need to subscribe to this channel. Question: compute Arima 3, 2, 3 model. What this simply means is that the auto-regressive part is of order 3, the differencing part is of order 2, and the moving average part is of order 3. Now, we now write the auto-regressive part of order 3 to give us the auto-regressive part of order 3 will give us 1 minus phi 1b 1 minus phi 2 b2 minus phi 3 b3. So this of order 3. The differential part, we have 2 here. It will have the 1 minus b raised to the power of 2. And the moving average part is of order 3 again. Now the moving average part is of order 3, which is 1 plus theta 1b 1 plus theta 2 b2 plus theta 3 b3. Now we should recall what we have as our model for the Arima. Yes, you should note that our Arima model is 5p v, our differential st to be equal to theta qb dt. So this is how our model is. So whatever we've gotten here, we'll now put it the way our model is. That is what we do. For more on this topic, you need to subscribe to this channel. Now, for me to do that, for me to write whatever we've gotten here as this, we move over to this side of the board to do it. So move over to this side. We have the Arima part, which is this part, our auto-reversing part, which is this part. We write it as first to give us 1 minus phi 1b 1 minus phi 2 b2 minus phi 3 b3. We have our differential part to be 1 minus b raised to the power of 2. So we have 1 minus b raised to the power of 2. Here we have our xt to be equal to, we have our moving average part, which is the whole of this, which is 1 plus theta 1b plus theta 2b squared plus theta 3 b raised to the power of 3, then et. Yes, this is what we have. Now, this is our model, and this model is looking like what we have here. But we can rewrite this out properly so that we'll be with the time series values only. Now, we should recall that we say note that 1 minus b squared xt is equal to, if we open this from quadratic equation, you can get 1 minus 2b plus b squared, then xt. Now, if we multiply this xt by this, we get xt minus 2 bxt plus b squared xt, which is the same thing as xt minus 2 xt minus 1 because of the backward shift plus xt minus 2 because of the backward shift before it. Now, the whole of this, we can take it to be xt double prime. So the whole of this we have is this. So we can write what we have here. We can write it as 1 minus phi 1b minus phi 2 b2 minus phi 3 b3 xt double prime. So that's what we have here. Xt double prime to be equal to 1 plus theta 1 b plus theta 2 b squared plus theta 3 b raised to the power of 3 et. This is what we have. Now we can open this bracket. We can open this bracket. If we multiply this with whatever that is inside the bracket, we have this multiplied by this, we have x t minus this multiplied by this, we have 5 because of the backward shift, we have x t minus 1 minus phi 2 x t minus 2 minus phi 3 x t minus 3 to be equal to et. This multiplied by this, we have plus theta 1 et minus 1 plus theta 2 et minus 2 plus theta 3 et minus 3. So this is what we have. Now, with this, we can now write the model itself. With this, we can write the model itself. For more on this topic, you need to subscribe to this channel. Now, we can write this our model to be ft to be equal to the whole of this can move over to this other side of the board to give us this phi 1 xt minus 1 plus phi 2 xt minus 2 plus phi 3 xt minus 3 plus theta 1 et minus 1 plus theta 2 et minus 2 plus theta 3 et minus 3 plus et. So this is what we have. This will not be the model we have written here. This is simply how we can compute Arima 323 model. Very simple. So for more on this topic, you need to subscribe to this channel. So with this, we take yet another question on Arima modeling. This is how we can simply compute the Arima model. So for me to do that, we have to delete or clean this part of the board. For me to take yet another question. So for more on this topic, you need to subscribe to this channel. For more on this topic, you need to subscribe to this channel. So we have here another patient, complete Arima 324 model. For this Arima 324 model, our auto-regressive part is of order 3, our moving average part is of order 4, while the differential part is just 2. Now, the first thing to do is to write the auto-regressive part of order 3. Auto-regressive of order 3. Auto-regressive part of order 3 will give us 1 minus phi 1, the backward shift 1 minus phi 2, the backward shift 2 minus phi 3, the backward shift 3. Also, the differential part is of order 2. We have differential of order 2, which is 1 minus b raised to the power of 2. Now, the moving average part is of order 4. The moving average part is of order 4. So we have m a moving average of order 4 will give us 1 plus theta 1 b plus theta 2 b2 plus theta 3 backward shift 3 plus theta 4 backward shift 4. So this is what we have. This is what we have. Now, the next thing to do, we say we recall for what we have as our model. Our Arima model says that we have 5p b, our differential of order d, xt to be equal to theta of order q et. So these are Arima models. This is exactly our Arima model. So whatever we have here, we will write it in this form. Whatever we have here, we will write it in this form. When we write it in this form, it means we have found the model for Arima 324 computation. So the first on our list is the A arrow part. That means this part. This part is what we first write. We write it this side. The A arrow part is 1 minus phi 1 b minus phi 2 b2 minus phi 3 b3. Then multiply by the differential part. Our differential part is 1 minus b raised to the power of 2. We also have our xt part, which is the time change xt, which is equal to, now we have the ma part, the moving average part, which is of order 4. So we write it as, which is 1 plus theta 1b plus theta 2b squared raised to the power of 2, or we put it here, we say plus theta 2 b raised to the power of 2 plus theta 3 b raised to the power of 3 plus theta 4 b raised to the power of 4. So that's what we have. That's what we have. That is simply our model. That is simply our model. If we can compare it with what we have here. Now, but we can still write this out properly. So it will be very easy for you to. So we say no, we have to know that 1 minus b all squared xt is equal to, from quadratic equation we can expand this to give us 1 minus 2b plus b squared, then multiply by xt, multiply by xt. We can use this xt to multiply the whole of this to give us xt minus 2bxt, this multiply by this plus b squared, that means the backward shift xt. We have already talked about how we can compute the backward shift in our previous lesson. Now we have this to be equal to xt minus 2. Because of the backward shift, we write it as xt minus 1 plus, because of the backward shift raised to the power of 2, we have xt minus 2. And this is the same thing as equal to xt. We can say, let's take it as this xt double prime. So we have this to be xt double prime t. So that means we can rewrite whatever we have here back. So wherever we see this, we put this. Whenever we see the one of this, we put this. So that means that our model will now be 1 minus phi 1b minus phi 2b minus phi 3b 3, then x t prime prime to be equal to, because the whole of this is this, to be equal to 1 plus theta 1b plus theta 2b squared plus theta 3 b raised to the power of 3 plus theta 4 b raised to the power of 4. So that is it. The next thing we do is to expand whatever we have here. We open the brackets. Then this, okay, this is ET. We put our ET here. And this, we also put our ET here. Sorry. We put our ET because we have the ET in our model. So that is it. This is our model. This is our model for Arima 324. We are only trying to expand this to open it. For me to do that, we have to use the backward sheets and the pressing part to be equal to this. Since this is equal to this, so wherever we see the whole of this, we put xt double prime. So we expand that. For me to do that, we move over to this side of the board to do that. So we can open this. If you open it, we have xt prime prime. That means if we multiply this by this, we have xt prime prime minus phi 1 x t t minus 1 minus phi 2 x t minus 2 prime prime minus phi 3 x t minus 3 prime prime to be equal to, now if we multiply et by this, we have first et plus, if you multiply et by the second one here, that means theta 1b, we have theta 1 et minus 1 plus theta t et minus 2 for the second one plus theta 3 et minus 3 for the third one plus theta 4 et minus 4 for the fourth one because we have a moving average start of order 4. Now, it then means that we can make this the subject of formula. We can make it the subject of formula to write it as ft to be equal to, that is ft prime prime to be equal to this. If you move the whole of this part to this other side of the equation, you have it as positive. So it will be phi 1 xt double prime plus phi 2 xt prime prime minus 2 plus phi 3 st minus 3 prime prime plus, we start with this. We can start with this. Theta 1 et minus 1 plus theta 2 et minus 2 plus theta 3 et minus 3 plus theta 4 et minus 4 plus et plus our error 10 or the white noise. So this becomes the model for the given Arima 324. This becomes the model for the given Arima 324. Or we can still write it as this, but expanding it, we write it as this. So for more on this topic, you need to subscribe to this channel to get more questions and more teachings on Arima model.